Unit conversions, this one, I'm going to be honest, is important, but it kind of sucks. All right? Couple things. You would have to do this. I can't even blame the U.S. customary system on this one because we have to convert units when we're doing physics. When there was, you ever heard of the Hubble telescope?
Yes.
Okay. Did you know that when it went up there, it didn't work and they had to go up there and fix it?
No.
Do you know what the problem was?
The satellite?
The problem, anybody know what the problem was?
No.
And why it came about?
The signal?
No, it wasn't the signal.
No, it's because we use different systems than.
What?
Didn't like.
Somebody converted.
Companies, wasn't it?
Yeah, somebody converted, went to do this unit conversion that I'm teaching, probably a little bit more complicated or a lot more, and screwed up. And they had the wrong units. And therefore, $1 billion later was a $1 billion mistake. I mean, just imagine. So we'll get you there. Okay, so for some of you, this is a stretch. Some of you, it's not. That's great. But if you're going to walk out because you got a conflict, grab one of these. It's also on your classroom, on the Google. Okay, so and unit conversion. But I'm going to use that, but I'm going to spend more time over here. So don't get the fancy lights over here. The real work's going to be probably more over here. Okay, and we're going to do something. We're going to convert inches to feet or feet to inches or something like that. Okay, in something that we know how we do it. So what we need is whenever we are converting, so let's say inches to feet, we have the desired units and the given units. So let's say I am 72 inches. Let's make it realistic. I am 69 inches tall.
Whoa.
All right. So what is the given units? Huh?
Said you got a guess, but real busy.
I am busy right now. Who? Oh, okay. Hi. Okay. All right. Oh, so he's gone. So whenever they do, you want to just all right. No problem. All right, so we're converting 69 inches. Let's go 68 and a half. Okay? All right, 68 and a half. That's probably exactly how tall I am. All right? So, given units. What's the given units? Inches. Okay, inches. So, we're going to put, all right, let's do this in red. I'm going to add a little spice. 68.5. 68.5 or a half, but we'll use 0.5 inches. And I put it over 1. That's the first thing I do. What is given to me, I put it over 1. Okay? Now be right. Given units over 1. Then I want to multiply it by desired units. What's my desired units? Feet. So 1 foot. I don't have time right now.
I thought you might just want to know this. The nurse kind of told me to come and tell you. I don't know where I cut my finger, but I might have cut it in your class again or something.
Again today?
Yeah.
Okay.
Yeah.
All right, and given units. Now, do you think, can I put 1 inch under here? Will that work? No, I need what we call conversion factor. What does, and that conversion factor needs to equal 1. Okay, let's put that away. If we're keeping notes, all right, conversion factor needs to equal what? 1 needs to equal what? 1. Okay, that's huge. So to equal 1, how many inches equal a foot? 12. You all know that. This is pretty simple, right? Now I multiply 68.5 times 1. I lose inches. Why do I lose inches? They cancel. All right, so I got 68.5 over 12. Okay, and I'm going to get whatever that answer is, which is what? There you go. So it's going to be 5 feet, 8 1/2 inches.
Is that multiplication, right?
That is multiplication right there. And we take what we're given, we put it over 1, then desired units, write that down over given units. Okay? Okay, again, conversion factor is 1. Third time. Okay? And then given units, it's gone, just right here. Inches, and we're left with feet. But again, this conversion factor is 1. But it has both units. And so that's why you're going to have, and to do this assignment, and I didn't make copies of it, engineering formula sheet. And it'll have all the conversions on it. Okay? So you're going to do that, you're going to need the engineering formula sheet that I'm going to have to dig out. Okay? The reason I'm pointing to you is because I know you got a conflict. Okay? Conversion factor 1. All right. So here's an example of with just math, right? So if we were to take this, we could take 7s, cross them out, and we go 5 over 3, right? Okay. Now, this is in your engineering formula sheet. You can also look this up, okay? So, online, do whatever, but we need to find the conversion factor of, if we're going, let's say we're going from kilometers to millimeters, or from meters to kilometers. What do we have? And they use exponents, okay? So 10 to the 1 equals what? 10. 10 to the 2. 100. 1,000. Oh, this is 100,000 because 10 to the 6.
Oh, 10 to the 6.
Yeah, that it went from 10 to the 3rd, 10 to the 6. So 6 zeros, you're right. It's 10 to the minute. Yeah. So if you got a megameter, it's 1 million meters. Okay. Then that's getting larger. That's going smaller. This is 0.1. 0.100.001. Cool. Okay. 0.1. That's not going to let me draw on this. So we got 0.1, 0.01, 0.001. All right. So, 10 meters. 1. So we look here. We have 10 meters. It's going to equal 1 decameter. Now, if we have 1,000 liters, it's 1 kiloliter. All right, we're going to 1 million. We just went through this. I'm trying to go through it All right, on this side. So if we have 0.01 centimeters, meters, I mean, 0.01, it's equal to a centimeter. All right, so I'm gonna go through this a little faster. All right, so given a unit, so grams to micrograms. So write this down. We're converting grams to micrograms. So we go to this, and it's 10 to the negative 6, okay? So that means 10 to the negative 6 grams, 10 to the negative 6 grams equals 1 microgram. That's what it says right here. What? 10 to the negative 6. Or 1 microgram over 10 to the negative 6 grams. Now this is what we need for our conversion factor right here. Everybody have this down? Okay. Yep. What's on the bottom? So given unit in denominator, desired unit in numerator.
What is that? Is that it?
Numerator, denominator. What?
For that, next to the 1 on the bottom, what is that? Is that an upside down 8?
That is this symbol right here. That's a Latin symbol that I couldn't tell you what it means, but it means micro. But that it's an abbreviation for micro because they ran on M's. Millimeter, M, right? So it's like they had to use something unusual that, so they did that. All right. So the reason why, and I when I was talking, you know, you have the numerator and the denominator. Right? It's on the bottom. It's lower. Okay? I just like to say that. All right. So we find the equivalency that equals 1 right there. All right. So are we feeling pretty good about that? Everybody feeling pretty good about that, John?
Yes.
Okay. All right, so we're going the opposite way. We're on the larger scale here. We're going megameters to meters. Okay? So, you know, like we use megameters or gigameters when we're dealing with like other planets, our solar systems, things like that for distance. Okay? So, but now we got to convert it to meters. We got 10 to the 6 meters equals 1 megameter. So again, that is positive 6 because we're on the larger scale here. Okay? And again, you might have to use this PowerPoint with these prefixes for some of the homework for right now until I get you the engineering formula sheets. Okay, so desired units, given units. And all we're doing right now, we're not solving anything. We're just finding the conversion factor, which is honestly the hardest part of this assignment, is finding the conversion factor. Now, all right, we already talked about that. All right, so let's do this. 103.2 centimeters to meters. Okay, and don't do it. I know how you were taught, right? Most likely. You had 103.2 centimeters okay? And since we're going from centimeters to meters, we move the decimal place over 3 times, done. Okay, I know you can do that here for this, but once we start getting more and more complicated, everybody needs to do it this way. And if you don't do it for the simple ones, it gets really hard to do it on the more complicated ones. So, what is our conversion factor? Okay, what's our given units? Centimeters. So, 103.2 centimeters, right? Put that over 1. Then desired units on top, given units on bottom. Desired units, we want meters. And what do we want for given units? All right, so we would have, and I'm going to go back. All right, because we got centimeters here. So 10 to the second meters negative equals 1 centimeter. Okay? Which that equals there. All right, and then we get this, we get rid of centimeters because we're doing that. And now we move our decimal place 1, 2, 3 when we multiply it, or we can put it in the calculator 0.1032 meters. Did I lose you? Yeah?
Yeah.
No.
Okay. I thought so. I was looking at, yes.
Wouldn't that only be, should it only be over 2?
Yes.
So how can you make it over 2?
I was wrong. Thank you, Marissa. So it'd be 0.01. Yes, it is. That's why I have the slides like this. Okay. Put that over 1. You got 10 to the negative second meter. Desired units on top. Now, some of you would rather do, and I don't care. You can. I will allow this. And when I say allow, I think this is okay for education. If you would put 1 meter here equals how many centimeters? So instead of doing it this way, 1 meter equals how many centimeters? 100. Now, this is what? 103.2 times 1 equals 103.2, right? Over 100. And now you would put that in the calculator, 103.2 divided by 100, and you're going to get 1.032 over nothing. Meters. Is that helping? Will, you getting this?
Yeah.
Why don't you sit right here? No. All right. Yeah, no, thank you, Marissa. Good catch. All right. Might want to remember this. This does help. Rules of exponents. This is on a slide that you got. Okay? Basically, if you have 10 to the 0, it's equal to 1. And there's an example of this right here. Okay? If you're multiplying 10 to times an exponent, it's the same as 10 plus m plus n. So here's an example of that. 10 to the 5th, that'd be m is 5. Negative 2 would be n. You'd add those, and it'd be 10 to the 3rd. Okay? These come in handy. And then if we have exponents where we have fractions, I have to come back to this because I can't always remember this. So just all right. Let's do this. And I want you to write this. You do it. I'm going to give you some time. But I'm going to kind of set you up here for a little bit. Convert. Well, I'm going to set it up as much as they have. 0.005 kilometers to centimeters. Okay? And the reason they did it twice, conversion factor twice, is because you're going from kilometers to meters, and then from meters to centimeters. So 0.005 km. Put that over 1. That does help. Then let's get it from kilometers to meters. So desired units on the top. Another way to look at it, I got kilometers on the top. If I want to get rid of it or change it, not get rid of it, change it, where would I put it? On the bottom. And I want meters. But it's asking for centimeters, so then meters here, meters down there, centimeters right there. And it already found the conversion factor for you. I think that was a mistake. All right, so 10 to the 3rd. 1 centimeter is 10. So if we go back, rules of exponents. What does that one look like? Does it look like this one?
I'd say the second one, 10 m times 10.
Here, we'll go. So we have, let's just figure 0.005 times 10 to the 3rd over okay, which would be the same as, if we look here, 3 minus 2. So 10. Minus 2. Right? So it'd be the same 0.005 times 10 to the 3rd to the 5th. Two negatives, right? And where do we go? What does that answer equal then? Okay, so times, so I just wanted to show how you got 10 to the 5th. So once we get that, how are we gonna go there? Where are we gonna go? How do we do this? 0.005 times 10 to the 5th. Anybody know? Anybody want to guess? Nobody knows? Like this is are we done? No? Do you know that? But we don't know what to do when we multiply 0.005? Yes, Marissa.
You use the decimal point to the right
5 times. Yes. So 0.005, we go 1, 2, 3, 4, 5. 500 centimeters. All right. So let's do this. Convert 519.67 hectoliters to megaliters. So desired units on the top. Yes.
Is it hecto 10 to the positive 2?
Yes. So,
Up there you wrote 10 to the negative.
thank you. Yes, it is. That would make it a little bit different. All right, yes. So we got 10. I was back there. So yes. And then now, how do we do this? Remember we have on the top, so it's the same as, let's go back. And I should have, whoops. I'm going to write this. Okay, so we're going to get right here times 10 to the second, because we go from here to here to here. So 519.67, we get rid of hectoliters, okay, and we end up getting rid of liters. Okay, but 519.67 times 10 to the second okay, times 1. All over 1 times 10 to the 6. Does everybody see how I got that? Okay, so now we come here where we have 10 m equals the same as 10 to m minus n. So then we would have 519.67 times 10 to the second power minus 6 minus n. So that would be to the negative 4, right? So then 519.67 is 10 to the negative 4. And then, which way does the decimal place go? Yep. So the answer, and you can type this in, right, as well in your calculator. You know, what is 519 times 10 to the negative? But this hopefully shows you how we get there. Now, I'm not going to worry about this for right now. We just want to get there. I'm not going to worry about like this. All right, but do we understand how the desired units over the given units? So if we're going feet to inches, we already did this. We're going miles to feet. And so we're going to have 5,280 over 1. All right, so let's convert this. This is a nice simple one for us. Now, how many can do that in their head? Somewhat close. How many convert that in their head? Good. I'm going to ask you to not to do it for now, okay? But no, what's the answer? What do you got?
51.6.
Huh?
51.6.
All right, good. That is the answer, okay? Now, but let's do it so that we get used to doing the conversion factor. So we got 17.2 yards. Put it over 1. What's the desired? Feet. Yards. Okay, how many feet in a yard? 3. So we got 3, 1. 17.2 times 3 is what?
51.6.
Over, and we get rid of yards, and we got feet, not over anything. I don't know why I keep saying that. Okay, I know, is there a quick, yeah, you've been taught just to divide that by 3, got it, okay? But I want you to do it this way because what's coming down the road. And we look here, 3 feet, 1 yard, conversion factor, that's equal to what, Samson? Just 3 feet over 1 yard.
1.
Yes, good. Conversion factor is always equal to 1. All right, so now we got 3 feet, 7 1/2 inches, 2 inches. Let's do that. Do that on your own. And I'm going to walk around and I want you to do it. Desired units, given units. Now, we already have a little clue. We already know it's 7 3/4 inches. Do we have to convert that? No, so don't. Just convert to 3 feet, then add the 7 3/4 after. Okay? And you know the answer, so you should be, but I want to see it. Do it like with the conversion factor, all right? Right there, let's do that. Conversion factor of feet to inches? You tell me. Yes. No. Nope. This, good question. When you are doing like, I am 5 feet, 9 1/2 inches. 5 feet, 9 1/2 inches. That's just to separate it, that dash, it's not a negative. Nick, you able to do that? Okay, so can you do that on there? I want to make sure that we're, before I, you got it done? Okay, so we're converting 3 feet. Put it over 1. Okay, what's the desired unit, Samson? Inches and feet. So we need to make this equal to 1. So what do I do? 1 foot equals how many inches? What? 12. Okay? And then I got to multiply, so we multiply the numerator first. 3 times 12 equals 36. 1, or keep doing that. But, so 36 inches plus 7 1/2, 7 3/4 is equal. So grab this. I want you to get as far as you can. If you are done with that, you don't have to listen to me and come into here and work with me. If not, that's fine. You just work with me until we're done with it. Yes.
So on like Friday, we were supposed to get 3.18. You gave us that.
Oh, because that's what was when you printed that. Okay, that is going to be, that is actually over in the black lab. Okay, so let's go grab that. No way.
So I got this
Do you have it done?
Yeah, it's done.
Okay. But did you do milk? Oh, yeah, yours. Okay. I'll just take it right now.
And then I got marked wrong the multi-perspective packet, but I did that.
The multi-view?
Yeah. I have like.
Oh, sweet, another pack that I.
Okay.
I had a lot of these.
Can you come in during lab time? Or
Yeah. Yeah.
Yeah, that's exactly what I'm gonna do.
So where is it? Just on the corner? Is
Yeah,
that it? Okay.
I suck at math.
I love math, dude.
I was good at algebra, but not geometry.
Really? Geometry is way easier.
It depends. Everyone's got a different thought process, I guess.
I guess.
I guess. Yeah.
This is next.